Yes, class. Hello. Am I audible to all of you? Priya, Adriel, Aditya.
Yes, ma'am.
Okay. Sorry, class. My laptop wasn't working, so it took me some time to join. So let us quickly start, as already 10 minutes have been wasted. So let's start with dipole moment. Yesterday, in yesterday's class, we had completed till electric field. Electric field we had completed. So what is meant by monopole? What is meant by dipole? Monopole is simply a system that is having a single type of charge. If I say electron, proton, these are independent single charges that exist. When I have two charges that have opposite signs, positive, one positive, other negative, but with the same magnitude, means if one charge is plus 5 coulomb, other has to be minus 5 coulombs only. So this type of set of two charges with a certain separation between them having same magnitude but opposite sign, this is called as dipole, right? So we calculate the dipole moment. The dipole moment's formula is very simple and straight. Just take the magnitude of one of the charges, because both the charges are having the same magnitude, so it doesn't matter whichever charge you take, and multiplied with the separation between both the charges, right? It's a vector quantity, so you have to keep in mind about the direction. What is the direction? From the negative charge, you will move towards the positive charge. That is the direction of electric dipole moment. Fine. SI unit is simple. Charge is coulomb and separation is meter. So coulomb meter. All right. So this is dipole moment, basics of dipole moment. Then from dipole moment, you have electric field at the axial line, electric field at the equatorial line. So see class, from axial line and from equatorial line, you have questions, but mainly in this dipole moment's value are given. Usually the values of dipole moment are given. So you just have to keep it in the formula. Whatever formula is there, that you have to just keep it. So E axial line is what? 2 kpr divided by r square minus a square. But you can use an approximation also, right? We all know about the approximation. But see, use the approximation after analyzing the question, after you have made an analysis about the question, that yes, the separation between the charges is very small as compared to the separation between that point of calculation. When r is very much greater than small a, that is the separation, then only we use ideal dipole approximation, and then only you get the formula 2 kp by r cube. Because in most of the questions that have come in JEE, you have the formula usage of the above one, not the ideal dipole approximation. So that completely depends on the type of question. Then same thing goes for equatorial line as well. Minus sign has to be added because direction is opposite. Whatever is the direction of dipole moment, some direction is there, no, left to right, right to left, depending upon the charge's sign. Axial fields, electric field will be exactly the same. But when we talk about equatorial field, it is opposite. So if your dipole moment's direction is from, let's say, towards the right, your equatorial field will be towards the left, and axial field will be towards the right. This is what the basis is, and the formula is also minus kp by r square plus a square to the power 3 by 2. Again, if you use ideal dipole approximation, it will be minus kp by r cube. Fine, one minus sign will be added and 2 will not be there. So this is just a basic summary of what is present in axial field and what is present in equatorial field. Learn both the formulas with dipole approximation, without dipole approximation. Remember the directions about it. Fine. So this is what you have to remember about dipole moment. Apart from dipole moment, one very important law you have is, that is Gauss law. So that also we have to discuss it. So first we'll discuss all the points of it. Then this is also very easy. Torque's formula only gets used. Class, from here you can get statement-based questions. Statement-based question as in when is the in one statement it would give you that net force is 0. In the second statement it would give you torque is 0. So somehow this you have to manage by yourself, whichever quantity is 0. So if it is plus q minus q, then net charge is 0. Whatever statements are based. So just be careful when you are dealing with force and when you are dealing with torque, right? Force is the translatory force. Rotational force's analog is torque, right? So one simple formula of torque you have, that is P cross E or PE sine theta. Derivation you don't have to do, so do not go into the details of it. Just remember it's a vector quantity. You have to find out P cross E, right? P cross E means P is the dipole moment, E is the electric field. So P cross E or PE sine theta. That's what you have to remember. Otherwise, no other detail is important for you because it's not a theory paper. Electric field lines property. In electric field lines, no class, you have to find out in electric field line the directions. Like for positive charges, are the field lines moving away? You have to, the figures will be mentioned to you, and these questions have come in 2021's paper as well, and in 2020's paper as well, where figures are given, direction of electric field lines are marked, and you have to identify whether these are correct or incorrect. So cylinders will, and this is a question from your NCERT as well, so it's a modification of that question. So if positive charges are there, field lines will be moving away. If it's a negative charge, it will be moving towards it. If a set of dipole is given, that is a positive and negative charge, then field lines will move from the positive towards the negative. So this much part, basics of electric field lines are sufficient because the details won't be asked. Or by chance, again, assertion reasoning type questions where statement 1 and 2, and out of you have to choose, out of all the given statements, you have to choose which are correct or which are incorrect, where the options will be given A and B are correct, B and C are correct, like that. So there the properties will be written and you have to identify. So that is not also very much difficult. Which topic is important is your Gauss theorem. From Gauss theorem, the applications of Gauss law which you have, the whole infinite plane sheet, infinite line, all those are very important, right? So electric flux is what, yes, we have to discuss electric flux. This is an important topic. What is meant by electric flux? See, electric flux you have and magnetic flux you have. So whenever flux is mentioned, be careful, read the whole statement and analyze whether it's electric flux given or magnetic flux given. Electric, you have some mention of electric field and directly connected with electric flux if nothing else is mentioned. Otherwise, electric flux and magnetic flux will be specified. But meaning of flux is basically field lines crossing an area perpendicularly to the surface. For example, this is the surface, then whichever field lines will be crossing this perpendicularly, normally making an angle of 90 degrees with the plane surface. That is termed as flux. So, for example, in this figure, there are 4 lines made. 4 electric field lines are successfully making an angle of 90 degrees and are crossing this sheet. So it means electric flux is 4, right? But C class, this was a very small number. It was just 4 lines were given, so I was able to calculate, and I have told you that the electric flux is 4. But what about the surfaces where electric field lines are uncountable, or where it is difficult to analyze it, or in terms of vectors only it is given? So there you have to have a proper formula for it. So we do have a proper formula for this. So electric flux's formula, basic, this formula is used, ES cos theta. So differentiation, integration, everything basics, I hope you all are clear by that. So electric flux's formula is E dot S. The simple basic formula is E dot S, ES cos theta. Torque was P cross E, PE sine theta, and electric flux is ES cos theta. So SI unit and all you can manage. What you have to remember is that if it is not constant, it is varying, then you have to integrate it. So your flux becomes integration of E dot ds. For a non-uniform surface, when you're seeing surface area is changing, it's not uniform, then you have to apply this form, integrate it simply. All right, for curved surface is also, you have to find out the surface integral like this. Flux will be E dot ds. So based upon this, based upon the whole concept of electric flux, we have Gauss law. So what is the statement of Gauss law? Gauss's law basically states the fact that electric flux, whatever we have discussed about electric flux, this is equal to 1 by epsilon naught times the total charge enclosed by the body. So when we are mentioning charge enclosed by the body, do not consider consider the charges that are present outside, even though if they are making an impact or they are not making any impact on the body. Just consider the charges which are enclosed within. The way in ampere circuit law also we take the current that is enclosed within the circuit. So similarly here also 1 by epsilon naught times the charge enclosed. So flux you can calculate in whichever way you want. E dot ds, integral of E ds, Es cos theta, just equate it to Q by epsilon. Rest of the properties and all are not very important from it. But I think let us start just practicing some numericals also from this. Some questions from dipole, let's do. First, try it by yourself. Take 2 minutes time, note the question, then I'll discuss it with you. Yes, class. Did you try this? Any answers? Okay, keep on trying while I'm discussing. Those who have reached the mid of the calculation, you reach the end and let me know whichever answers you are getting. Till the time, let me start discussion. So it says that two identical electric dipoles have dipole moments P1 as pi cap and P2 as pi cap. Okay, both are pi cap. They are held, both are pi cap. All right, they are held on the x-axis at a certain distance. This one will be minus pi cap. Class, just this is minus pi cap. So both are held at a certain distance a from each other. When released, they move along the x-axis with direction of the dipoles remaining unchanged. Okay, direction remains unchanged and they move along x-axis. So one will be towards plus I cap, second will be towards minus I cap. This is it. Mass is given m. Speed we have to find out when they are infinitely far apart. Class. See, whenever you have any question that has speed in relation, and it's not a question of particularly speed like escape velocity and all these are not mentioned, and out of nowhere speed is asked, right? And such questions like here also there isn't any relation of speed and charges, no. So directly use the concept of conservation of energy, because there you'll have potential energy, from there you'll be having kinetic energy, and it's the involvement of kinetic energy only that include speed in the whole concept. Fine. So we'll do the same thing. So see, when two electric dipoles of opposite dipole moments, they are placed on a line, they experience force of attraction along the same line. So how do they experience that? See, suppose, let me draw this. This is P1, mass is m, same way. This is P2, mass is m. Both the dipoles are having the mass m. No? Now see, you have to consider that both the dipoles as a system. This is your system now. System, and I hope system and surrounding you understand. Isolated system. So this is a case of isolated system. When the net external force on the system is 0. So here net external force is 0. Net F net external is 0. So in your system, this is your system containing two dipoles, right? External force is 0. Whenever your external force is 0, this criteria is satisfied, then only you will use the term conservation of energy. So total in conservation of energy, what is meant by conservation of energy? This simply means no, the total mechanical energy remains constant, right? So whatever is initial mechanical energy is equal to final mechanical energy. Total mechanical energy, it remains constant. It means initial mechanical energy. Mechanical energy is what? Sum of kinetic and potential, no? So initial kinetic energy plus initial potential energy is actually equal to final kinetic energy plus final potential energy. So initially they are released from rest. That is also mentioned. They are initially released from rest. So if they are initially released from rest, that means initially velocity is 0. So initial kinetic energy directly becomes 0. So one thing that is clear is, since they are released from rest, so initial kinetic energy becomes 0 because they are released from rest. All right. What about the potential energy? So yes, potential energy will exist. So potential energy we haven't discussed because that's actually a part of the next portion. So, but even without that also, you can, at least you all have the idea. You all have appeared for your board exams. So finally, formula for potential energy initial. This will be 2 minus, also we'll put K P1, P2 dipole moment and cube of the separation with obviously the angle cos 180 degree, because cos theta is what? Both are at, they are anti-parallel to each other. So that is cos 180 degree. R cube cos 180 degrees. And what about the final kinetic energy and final potential energy? See, final kinetic energy will simply be half mv square. That v you can assume, right? So let me write down the full. And yes, one more thing, class. Finally, it is given in the question, they are far apart from each other. Infinitely. The separation between both the charges is infinite. So now, will they be able to exert force on each other? See, how do we consider kinetic energy and potential energies in our system? If motion occurs, movement occurs, we say kinetic energy is existing. But when there is interaction, means force has been exerted on each other, then we say potential energy exists. So if they are at infinity, they are separated by infinite distance. So will there be any force of attraction between them? Will there be any potential energy even? So final potential energy will also be zero. This, yes, this will also be zero because the separation between them is infinite, infinitely separated. All right. So yes, initial kinetic energy 0 plus minus 2k p1 p2 cos 180 degrees divided by r cube. This is equal to now half. Let's see what you have to do. Mass, we can write it as m1 also. We can write it as m also, because we already know this fact that m1 is equal to m2. Both are given as m. And same thing is about the dipole also, actually. This is P1 and P2 both are equal to, we can write it as equal to P also. And R is actually the A separation that is given. So let me first write it in terms of M1 only. M1 V1 square plus M2 V2 square. Both the masses are equal. That is given in the question, right? Both the masses are equal. So let's substitute it. So this will become 2k p squared by a cube. P1, p into p, this became p squared minus 1 into minus 1 plus. And here this will be equal to, yes, velocity is not equal. So we'll write half m v1 square plus half m v2 square. But now we'll not be able to solve this further, right? So one more thing which connects velocity apart from conservation of mechanical energy. Can you name one quantity whose conservation will lead to the involvement of velocity? Anyone? A physical quantity whose conservation involves velocity. Momentum. Right? Formula of momentum. Do you remember the formula of momentum? Mass into velocity. So when you conserve momentum, conservation of momentum leads to involvement of velocity. So here, if we are stuck, we'll use conservation of momentum because conservation of momentum is also valid. So we have conservation of momentum. So in conservation of momentum, initial momentum is equal to final momentum. Don't be confused with dipole moment. That is also P. This is capital P. So here also m1 v1 plus m2 v2. This is the final momentum. Initial momentum is 0. So you have v1 equal to minus v2. It means you can equate v1 is equal to v2 also as v. We were writing m1 and m2 same as m. Dipole moments also equal. Velocities had no mention, but when you apply conservation of momentum, you will conclude that velocity is also equal. Now it's just a one-liner solving. This was the physics that had to be applied. Now rest is just calculation. mv square, it will become 2k p square by a cube, right? 2k p square by a cube. So velocity will become from here to k p square divided by m a cube, right? So we can do one thing. We can take this. This is actually v square, no? So for v, we can take p out, and a also out. So what will be left? Under root 2k and 1 a will also be left, right? So this is it. Yes, you have your answer. So P by A under root, this is, write it as 1 over 4 pi epsilon naught. So that will become 2 pi epsilon naught M. Which option is this? B option. B option is the answer. Clear? Noted down. Wherever doubts you are having, get it clarified. Some more questions we'll discuss then.
Ma'am, can you explain the half M1V1 square plus half M2V2 square?
See, you have one dipole whose mass is M. This is mass M. Velocity will be something, velocity is something. Let's say this is M1, M2, V1, V2. So when initially kinetic energy is 0, why is initial kinetic energy 0? Because it is given at rest. Now, if I tell you, if I ask you what is the kinetic energy of this, what will you say? Half M V1 square. And kinetic energy here, half M V2 square. M1, M2, right? So what is the total final kinetic energy? This, right? So this is exactly what has been written. Then we can substitute that masses are also same. So mm, then using conservation of momentum, we can conclude that velocity is also same. So when you write VV, so that becomes half mv square plus half mv square, that is mv square only. That's why I have written here mv square. Clear?
Yes, ma'am. Thank you.
Yes, good. Priya Darshini, perfect. See, in a non-uniform field, force doesn't cancel out and has a net force, right? C class, I'll just show you the figure, those who are having any doubt in this. If I take non-uniform electric field, they'll be in this manner only, random directions. They are non-uniform, they can have any distance, some can be closer to each other also like this. See, this is, let's say, a dipole that has been kept plus Q, and here we have minus Q. So see, one force will be here, that is, let's say F, one force will be here, let's say this is F1, this is F2. So will the forces cancel each other? No, the forces will not cancel each other. In a non-uniform electric field, the dipole experiences, it may experience both non-zero torque as well as translational force also. So if you look in the figure, F1 is not equal to F2. Why is it not equal? Because electric field is not uniform. Forces formula is QE, right? Charge is same, magnitude of charge is same. Q1, Q2, both are having the charge same. But electric field's value is different, right? Value of electric field is different because it is non-uniform. So it means it would be some E1 for F1, F2, it would be some E2. That's why they are not equal. So when forces are not equal, it will be having some value of translational force, right? Because they are not canceling each other. If they cancel each other, then only we get zero. Right now, they are not canceling each other. So some translation force will be obtained depending upon their magnitude, F2 minus F1, F1 minus F2, however we calculate it. That's not our concern right now. Secondary torque, regarding torque. So same thing, torque is equal to P cross E. Electric field is not same, some amount of rotational force will also exist. So rotational force as well as translational force, which you can say torque as well as translational force, it may experience. See, fine. Note it down quickly. Let us now see questions from electric flux. Some good questions are there from electric flux portion. Quickly note it down and we'll see those questions. Look, class, yes. Any answers? Adriel, Priya, Aditya. It is clearly saying you that parallel to the YZ plane. So which axis according to you is parallel to the YZ plane?
X-axis.
X-axis, right. So it means just consider the X term portion. You are not concerned with 3 by 5 E naught J cap now, because it has clearly mentioned you just take care of the thing that is parallel to the YZ plane. And if this is, see if this is a plane like this, so this and this axis, this axis and this axis, this is what YZ plane, right? This axis and this, so this plane becomes what? XZ plane, right? XZ plane. This is simple, this plane is simple, XY plane. When I talk about this part, this is XZ, and when I talk about this part, that is YZ. So perpendicular to YZ axis is your X-axis, right? YZ plane, perpendicular to it is this. This is how your axis look like, right? Z, Y with X, like this. So same thing is here only. X, Y, you have to consider the XY plane. So only X-axis, you have to consider the X-axis. X-axis is, now see, area, just a second. Area is given how much? 0.4 meters square. See, area is given 0.4 meters square. And what's the formula for electric flux? Electric flux's formula is EA cos theta. Cos theta, here you will take cos 0 because it is given it since it is parallel. So we have to consider the area surface, we have to consider the angle as 0, because if it was given anti-parallel, you would have taken 180. If it would have been given normal, you would have taken 90. So simple EA. So yes, only consider now the 2 by 5 component. So 2 by 5 into E naught multiplied by area is 0.4. And value of E naught is also given to you. So this calculation you can do by yourself also. Flux will be 2 by 5 into E naught is 4 into 10 to the power 3 into area, that is 0.4. So when you solve this, this will be around 640 Newton meters square per coulomb. So this was yes, Satriel, correct. 2. Let us do some questions on statement based on the application of it. Note down those who haven't done it. I'll give you some statements, true and false part we do it, because that will cover the properties and formulas as well from that. Yes, class, it looks like a very long question, but if you just go by the details of what has been written, you will be able to figure it out that it's not very difficult, or the calculation part is also not lengthy. So see both the statements, let me know whatever is your answer. Both are true, both are false, first true, second false, second true, first false. Let me know. Okay, Aditya has answered, others also. Yes, I think all of you have answered. Those who are saying B, your answer is right. See the reason. Those who are getting both false. See, net charge on electric dipole. What is the net charge? See, net charge on an electric dipole, this is equal to plus Q minus Q. They cancel each other, you get 0. So if you put this into Gauss law, so electric flux will be what? Q net divided by epsilon naught, which is equal to 0 by epsilon naught, that is 0. And electric field due to electric dipole is non-zero now, right? And varies point to point. That's why the first statement is true. First is also true. Some were having confusion regarding first true or false. No, first is also true because net charge is 0. So flux also becomes 0, right? When we talk about the second statement that is given, we do have a formula. Electric field is equal to 1 over 4 pi epsilon naught QR divided by R cube. That is the electric field due to charged solid sphere. For solid sphere, all the spheres are very important for your entrance part. Fine. So here radius small r is, this is also a condition. So this is non-zero. Clearly this is non-zero. That's why second is false because it was saying it is 0. Right. So clearly this is false. So the option correct. One numerical also, let's practice. Theory part, I think, yeah. Class, this is an easy question. These types of questions will come. That means they can come. Where the charge is placed at the corner, where the charge is placed at the edge of it. So be prepared with these cube questions. When it is saying Q at a separation of 6 centimeter from the base, this means if you cover the whole cube, it's like from this entire whole cube, you are having, yes, Priya. Not, I think it's exactly 226, but good, good. I think you must have rounded off, right? Good, Priya. So if it is at the center, it's like inside a cube, the charge is kept at the center. Fine. So see, it's like if within this whole cube, let's say within this whole cube, the charge is kept. So what can I say about it? I can say the entire flux. Flux is total flux is Q divided by epsilon naught. Total flux through one cube. I can say flux through the cube is Q by epsilon naught. What is meant by one cube? How many faces are there? 6 faces, right? So I can say instead of this one cube, I can write it as through 6 faces. This is Q by epsilon naught. So through any face, any single face, one face, it would be Q divided by 6 epsilon. Right, this is what we had to find out. 12 microcoulomb was given, no? 12 into 10 to the power minus 6, 6 into 8.85 into 10 to the power minus 12. So as rightly answered by Priyadarshini, this would be 226, the value, 226 into 10 to the power 3 Newton meter square per coulomb. This came last year only. Fine, note it down. Last question for today. Please try this question, all of you. At least whatever answer you're getting, options I'll give you this time. C class, flux is given to you. We have electric flux. We can write this as rate of change of flux with respect to distance. When you will use this, if you differentiate this, so minus differentiation of AR square, that will give you 2 will come, then AR to the power 2 minus 1, that will be 1. So that will be minus 2AR. Now you will apply Gauss theorem. Fine. So when you will apply Gauss theorem, you will be having the value E dot S. So instead of, you can write E. Now S surface area is going to be what? 4 pi R square, right? Because sphere is given to you. So this area, this will be 4 pi R square. This is equal to Q divided by epsilon naught. Now Q, this is, if you will substitute it from here, all the values, just find out the value of it. So this is 2AR epsilon naught 4 pi R square Q. So Q is going to be minus 8 pi epsilon naught A R Q, right? R into R. This is the value of charge that you have. Now, what is the value of surface volume charge density? See, yes, what is the value of surface charge density? So, volume charge density, this is rate of charge, change of charge with respect to volume, right? Charge divided by volume, that is what we are going to write. So one method is multiply and divided by dr. Multiply and divide this whole term by dr. So you will get volume directly also. One method is this. So when you write this, this will be, volume is 4 by 3 pi r cube, right? Volume is 4 by 3 pi r cube. So 3 goes up, that becomes 24. So minus 24 pi epsilon naught a r square, because 1 r, this is going to get cancelled, into this is 1 over 4 pi r square, right? So 4, this becomes 6. Pi gets cancelled, r square gets cancelled. So minus epsilon naught a. So which option was this? First or second? This is minus C. Okay, C option is right. Note it down. Just text me done once you have written it. Then I'll stop the class. Quickly note it down.